Look at the confidence interval for the population mean. A lot of times we'll have a population and it's just not practical to figure out what the population mean is. It's either impossible to count the population, or it's too expensive, too time consuming, or just otherwise some logistical problem. So what we do is we take a sample from the population and then we calculate a sample mean. Then we use this sample mean to estimate what the true population mean would be. And just like when we were doing the confidence interval for the population proportion, when we estimate the population mean, we're going to use a confidence interval for our estimate. And here is how we estimate that population mean. We take the sample mean, which is denoted by x bar, plus or minus a t-value at alpha divided by 2, multiply that times the standard deviation of the sample divided by the square root of n, which is the sample size. Okay, so let's talk a little bit more about this t-value at alpha divided by 2. We have seen z-values before, but we haven't seen t-values. So what we're doing here is the z-value works for a standard normal distribution. But when you don't know anything about the population, it's very dangerous to assume that it's normal. So we use a t-distribution, which is a much flatter distribution, which allows for non-normalcy in the data. We won't get into the details of the t-distribution, how it was created. We'll leave that for another video. But for now, let's take a look at how do we get that t-value. Well, to find the t-value at alpha divided by 2 in Excel, we have to remember that alpha is the significance level, which is 1 minus the confidence level. So there's a formula in Excel called t.inv, or t inverse, and the way we set it up is 1 minus the confidence level divided by 2, because it is a symmetrical distribution, and then comma n minus 1, which stands for degrees of freedom, which you don't need to really worry about right now. We'll get into that at another time. Another way you could do it is t.inv alpha divided by 2, which is the same as 1 minus the confidence level divided by 2. I prefer to use the confidence level because when you're setting these problems up, that's what you're usually starting with, is the confidence percentage that you want to hit. Okay, so let's take a look at this in action. So here we have a problem. Our sample mean is 53. Our standard deviation for the sample is 2. Our sample size is 200, and we have chosen a confidence level of 95%. So first to calculate the t-value, and I added this ABS, which stands for absolute value, so that when I get my t-value, in case it has a negative number, it gets rid of that, and I can put it directly into my other formulas and not worry about whether it's positive or negative. Otherwise, it's the same t.inv formula. Okay, then I simply set up a lower limit formula and an upper limit. So B3 in this instance stands for the cell that would hold my sample mean, or 53. B8 is this t-value. B4 is the standard deviation, and B5 is the sample size. So it's really just taking the formula that we looked at earlier and putting it into a spreadsheet. So let's just take a look at an answer real quickly. So here's what this would look like if we worked it through. Same numbers. Our t-value is 1.97. Our lower limit 52.72, and our upper limit is 53.28. And the way we do interpret this is we have a 95% confidence that this confidence interval of 52.72 to 53.28 contains the true population mean. We still don't know what that mean is, but we're 95% sure this interval contains it.